following is a video over 0.6, which is linear inequalities. And when I use that word inequality, that means that two quantities are not equal to each other. Okay, so what I would want to say here is that an inequality shows that one quantity is larger or smaller than another quantity. So let's take something like this, for example. Let's say that I have the number 2. 2 is a number that is less than, which is smaller than 10. Okay, consequently, you can reverse this and say that 10 is larger than 2. Okay, and we always know which one is larger because of, you may either think of the Pac-Man eats the larger number from that game when we were growing up, or you could think of the shark that is about to eat the larger number. Okay, and I'm a big fan of the movie Jaws, and so we think of the shark, or at least I do. Okay, so one thing that we do need to consider here is that when we have an inequality statement, and let me write one. Okay, let me just say that I have the number 100. Okay, the number 100 we would say is larger than -1. Okay, we know that that's a true statement. Okay, any negative number is going to be smaller than any positive number. Okay, but let's just do something for a second. Let's say that I multiply 100 by the number -2. And we know from solving equations and doing algebra that if I do something to one side, I have to do it to the other. So I'm going to multiply this by -2 as well. And then I get the statement that -200 is greater than +2. And this is false. Okay, this is a false statement. Okay, because -200 is much smaller than +2. So in order to make this true, I have to take -200, and then I have to reverse my inequality symbol and say that -200 is less than 2. Now we have a true statement. Okay, so what we want to say here is that if we multiply or divide, by a negative number, then we must reverse the inequality symbol. Okay, inequality symbol. All right, it's important that we do that because that will keep things true. Okay, we start off with a true statement, we manipulate it, we got to make sure that it's true. Okay, so if we multiply or divide by a negative number, we have to reverse the inequality symbol. Okay, so let's take a look at some of these things and talk about how we solve them and how we need to write this. If I'm solving linear equalities, I'm going to solve them the same way that I would any equation. Okay, but we've got to make sure that if we multiply or divide by a negative, we have to reverse my inequality symbol. So what I'm going to do here to solve this inequality, I'm going to, since I'm subtracting 17, I'm going to add 17 to both sides. And I'm going to end up getting that x is greater than 12 plus 17, which is 29. Okay, and this means that all values of x are greater than 29. If it's smaller than it, this is not true. It's not a solution. Okay, but that's how we want to write our solutions. Okay, here, y plus 11 is less than or equal to 5, so we could equal 5, but we want to be less than that if we plug a value in for y. So if I subtract 11 from both sides, then I'm going to get y is less than or equal to -6. Now, I subtracted 11. I didn't multiply by a negative number. I didn't divide by a negative number. So I keep my inequality symbol the same. Okay. All right, let's take a look at the next example. Okay, and this one is if we multiply or divide by a number. So I'm going to rewrite this. Now this number is positive, okay? I've got t divided by 6 is greater than or equal to 11. So if I multiply by 6 on both sides and solve for t, because I was dividing by t, the opposite of division is multiplication. So this divides out, and I get that t is greater than or equal to 66. Okay, now I didn't reverse my inequality because I didn't multiply or divide by a negative. Okay, so now then over here, I've got 8 times some number p is less than 72. I'm going to divide by 8 on both sides and divide by 8. So then I get that p is less than 9. Okay, keep my inequality symbol the same because I didn't multiply or divide by a negative number. Okay, let's take a look at another one. All right, so now on this, I've got negative 5 times some number c is greater than 30. So if I divide by negative 5, now I'm dividing by a negative, and divide by negative 5, then I get c, but I have to reverse my inequality symbol at this point because I divided by a negative, is less than negative 6. Okay, so that's the only thing I got to do there. It's the only special case that I've got to consider. Okay, let me rewrite this over here. Negative d over 13 is less than or equal to negative 4. I'm going, because this is negative over here, I'm going to multiply by negative 13, multiply by negative 13. And so since I multiplied by a negative, this all divides out. I get d is greater than or equal to, I have to reverse this, is equal to 4 times negative 13. That's going to give me positive 52. Okay, and that's my answer. All right. So then let's take a look at the other one, at another one. This is a multi-step. All right, so we've got a lot of things to consider here. I need to isolate my a. Okay, I'm going to subtract by 13 on both sides, and so I end up getting negative 6a is less than negative 20. Okay, and then I'm going to divide by a negative 6. Okay, and if I divide by negative 6, that means I have to split my inequality. So this divides out, and so I get a is greater than, negative divided by a negative is a positive, so I get positive 10 thirds. Okay, well I should get, you should get 20 over 6, but that I can divide each of those by 2, and that's what ends up giving me 10 thirds. Okay, so I did some simplification. I skipped a step. Okay, but that's what you would get as a fraction, and then you can simplify that down. Okay, so then over here, I want to get my z's on one side of the inequality and solve for z. So I'm going to subtract 4z from both sides. Okay, and my next step, I'm going to write 7 is greater than or equal to 8z minus 4z. That's actually just going to be 4z, and then minus 1. Okay, I'm going to then add 1 to both sides. And so then I get the value 8 is greater than or equal to 4z. Okay, I'm going to divide by 4 on both sides. And I'm not dividing by a negative, so I don't have to flip my inequality. If you had moved the 8z over first, then it would cause you to have to flip the inequality. Okay, I'm going to do those divide out, and so I get this. I get the statement that 8 over 2, which is, 8 over 4, which is 2, is greater than or equal to z. Okay, so that's solving linear inequalities. I solve them the same way as I would equations. It's just that we get these mathematical statements in the end. Okay, so I hope you enjoyed this video. I had just an absolute blast making it.